Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0013-01, relates to a malfunction of the Variable Valve Timing Control, VTC, Oil Control Solenoid Valve B, in the Honda CR-V 2023 and newer models. This issue is specifically identified when the return signal of the VTC Oil Control Solenoid Valve B fails to align with the output signal as expected by the Powertrain Control Module PCM. The role of the VTC Oil Control Solenoid is to regulate the flow of oil to the VTC system, allowing for optimal valve timing for enhanced fuel efficiency and engine performance. Located near the engine cylinder head, the solenoid is integral to managing the variable valve timing. If the PCM detects an inconsistency in the signal, it triggers the storage of this fault code, indicating pending malfunctions in engine operation and performance. Addressing this code promptly is essential to maintaining vehicle efficiency and preventing further engine issues. The DTC P0013 indicates a malfunction of the VTC Oil Control Solenoid Valve B. This component is critical for controlling the flow of engine oil to the VTC system, directly impacting the engine's valve timing. The Powertrain Control Module, PCM, which is the central computer managing engine functions, recognizes an abnormality when the return signal does not change as expected according to the output signal. This issue often implies that the response of the solenoid is not functioning as it should be, which can lead to suboptimal engine performance. The solenoid valve itself is located on the engine cylinder head, making it accessible for inspection, but not easily visible without some disassembly. In summary, any malfunction in this component can significantly affect vehicle performance, causing erratic engine behavior or even increased emissions. There are several potential causes that can trigger DTC P0013. Firstly, a faulty VTC Oil Control Solenoid Valve B is a common culprit, as wear and tear over time may lead to its failure to respond correctly to PCM signals. Secondly, there might be issues in the external circuit that connects this solenoid to the PCM. For instance, open wires or short circuits can disrupt the electrical signals necessary for proper operation. Lastly, if both the solenoid and the external circuit are functioning correctly, the PCM itself may be at fault. A malfunctioning PCM can misinterpret signals or fail to operate the components due to internal issues. Thorough troubleshooting of these areas is essential to pinpointing the root cause accurately. Drivers may notice several symptoms associated with DTC P0013. One prominent symptom is reduced engine efficiency. Unexpected changes in valve timing can lead to poor fuel economy. Additionally, erratic engine behavior such as rough idling, stalling, or lack of power during acceleration may occur due to the solenoid's improper function. Also, increased emissions might be observed as a result of faulty valve timing, adversely affecting combustion processes. If the engine runs too rich or too lean because of this malfunction, it can lead to environmental concerns and potential failure during emissions testing. Recognizing these symptoms early can assist drivers in seeking timely repairs, thereby preventing further damage to the engine or related systems. The first step in troubleshooting DTC P0013 involves starting the engine and allowing it to reach a steady state. It's crucial to hold the engine speed at 3,000 revolutions per minute, RPM, without any load until the radiator fan activates. This procedure helps establish the operating conditions required for the VTC system to be evaluated accurately. After holding the RPM, the Honda Diagnostic System, HDS, must be utilized to check for specific signals and any fault indications in the VTC system. By conducting this initial test, technicians can gather vital data on the system's performance conditions and establish a starting point for further diagnostics. In the second troubleshooting step, direct inspection of the VTC Oil Control Solenoid Valve B is necessary. Begin by disconnecting the connector from this solenoid to access the terminals safely. This inspection includes checking the internal electrical circuit of the solenoid, which is critical for its proper operation. Technicians should measure the resistance of the solenoid's internal circuit between 7.14 to 7.9 ohms at room temperature. If the resistance falls outside of this range, it indicates an internal fault within the solenoid, necessitating its replacement or further repair. Paying attention to these details is essential to ensure the effective functioning of the VTC system and the overall engine performance. Step 3 focuses on inspecting the external circuit associated with the VTC Oil Control Solenoid B. Disconnect both the solenoid and the powertrain control module, PCM, connectors before beginning this inspection to prevent further complications. Key to this step is checking for any open wires in the VTC circuit, which should register less than 1 ohm in resistance. And similarly, performing the same test for the power generation PG circuit. Identifying open circuits is critical, as any disconnection will prevent the solenoid from receiving the correct signals from the PCM. If the resistance values are higher than expected, this indicates potential wiring issues, which need to be remedied to ensure that electrical continuity is restored throughout the system. The fourth step in the troubleshooting process requires checking for shorted circuits in the VTC system. After confirming that open circuit issues are resolved, it's essential to inspect the VTC circuit for any shorts to ground. Conduct this check by ensuring that the resistance measured is above 1 megaohm, MO. If the resistance is lower than this threshold, it signals that the circuit may be grounding out, which must be corrected to prevent PCM malfunction. This thorough examination is essential, as shorts can lead to uncontrolled VTC operations, resulting in further engine performance issues. Ensuring complete electrical integrity is paramount when addressing the VTC system effectively. The fifth and final troubleshooting step centers around inspecting the PCM to ascertain its functionality. Should the previous inspections, specifically related to the solenoid and its external circuit, return normal results, then the PCM may be identified as a potential cause of the issue. The PCM, acting as the brain of the vehicle's engine management system, must function without internal defects to send appropriate commands to the VTC solenoid. If tests reveal no issues with the solenoid or wiring, yet the DTC persists, the malfunction may lie within the PCM itself. Consequently, if necessary, the PCM may need to be replaced or reprogrammed by a qualified technician to restore optimal operational conditions. After performing the necessary repairs based on the troubleshooting steps, it is essential to verify that the repairs were successful. Start this verification by clearing the DTC codes from the PCM to reset its memory. Following the reset, a test drive of the vehicle should be conducted to allow the engine to reach normal operating conditions and to ensure that the VTC system is functioning properly without activating the DTC again. During this test drive, monitor the engine's performance closely, paying attention to any unusual symptoms or behaviors that may indicate residual issues. This verification process serves to confirm that the repairs addressed the root cause of the DTC and that the vehicle's performance has returned to its optimal state. Preventive maintenance plays a critical role in reducing the chances of encountering DTC P0013 in the future. Establishing a regular inspection schedule for the VTC system can help identify signs of wear and tear on the solenoid before it leads to a malfunction. It is also vital to keep the wiring intact and free from corrosion or damage, as electrical integrity is crucial for the effective operation of the solenoid and the PCM. Additionally, routine checks of the engine oil quality and level are necessary to ensure that the VTC system operates under optimal conditions. Using high-quality oil that meets manufacturer specifications can help prolong the life cycle of the solenoid and the VTC components. In summary, a proactive maintenance approach minimizes the risk of future issues and keeps the Honda CR-V running at peak performance. In conclusion, addressing DTC P0013 is fundamental for maintaining the Honda CR-V's performance and efficiency. Prompt identification of VTC system malfunctions aids in avoiding potential engine complications or increased emissions. Following the structured troubleshooting steps allows technicians to systematically diagnose and repair the underlying issues effectively. Furthermore, performing regular preventive maintenance can significantly reduce the likelihood of recurring problems, such as those associated with the variable valve timing control system. By understanding the roles of the components involved and knowing how to properly inspect and maintain them, Honda CR-V owners can ensure the longevity and reliability of their vehicles. Please like and subscribe to the channel. See you next time.